Let's look at finding the probability a couple having a baby boy when their fifth child is born, given that the first 4 children were all boys. So the key word here is this given. So this is a probability that the fifth child, the fifth is a boy, given the first 4 were boys. Well, the thing you have to be careful with probabilities is if these events are independent, and they are. I mean, who cares if the first 4 were boys? The probability of the last boy getting a boy out of a boy or a girl is still going to be 1/2. Okay, so if you want to go, if that's not that understandable and you want to go by the actual formula, let's say we call this event B and we call this event A. Well, the formula says B given A equals the probability, that should have been a B and A over the probability of the given. Okay, so that's the formula. But the probability of B and A when they're independent is just simply the probability of B times the probability of A over the probability of A. And notice, so what's the probability of B? The probability that they'll get a boy. Well, there's 1 in 2 chances. They either get a boy or a girl. Well, then the question will ask and say, assume that this is equally likely. Is the results the same as the probability of getting all boys? So what this is asking is the probability 1, 2, 3, 4, 5. And this is not going to be the same because, one, your denominator is going to be a lot larger because there's going to be how many ways can you do this. And I mean, you could start out just drawing a tree and say, okay, the first child's a boy, the second child's a boy, the third child's a boy. And as you can see, you're going to have all of these different outcomes that's going to end up being your denominator. So it's going to be a lot larger. So the second event certainly is going to involve a lot more possible outcomes.